Hey guys, so the new unit that we are covering deals with proving identities. Basically what these questions are asking you to do, what this booklet is asking you to do, is to take the left-hand side of the equation and the right-hand side of the equation and make them looking the exact same way. So how you're going to do that is you're going to basically manipulate the left side and the right side of the equation using formulas, using different tricks that we have learned up to this point, things like tan being sine over cosine, secant, cosecant, cotan, knowing those things, common denominators, factoring, all the different things that we have learned through our time in math in grade 12 and 11, and try to apply them in order to make the left side look a little different and or the right side look a little different, and then that way they can match exactly the same. So on page 2 in the booklet that I'm with you guys right now, there's a bunch of different tips and tricks and all those types of things that can help you as you work through identities, okay? And a toolbox at the bottom with different things that we've done in math up to this point that can really help us out. So hopefully in these couple of questions in the video, it can show you different ways of doing it, and then try to use other ways that you might think of as well as you're solving these questions. So on the left-hand side, we have 1 minus cos squared theta. And then on the right-hand side, we have cos squared theta times tan squared theta. Now, one of the tricks or hints that it tells us in solving identities is it's probably a good idea to start on the more complicated side of the identity. Imagine instead of an equal sign that we have basically a wall down the middle, which is exactly what we have here. So I have to treat the left side like its own question and the right side like its own question. I would argue in this case the right side might be a little bit more complicated, and the reason is the right side has cosine and tan, whereas the left side only has 1 minus cos squared theta. So on the right-hand side, I'm going to use one of our other hints or strategies, and I'm going to try to turn the right side into just sine and cosine. In most of the questions that we have, we'll be able to change everything we have into sine and cosine, because tan we can do in terms of sine and cosine, cotan, cosecant, secant, all those things we can turn into sine and cos. It's a lot easier to deal with a question that has only 2 functions versus a question that has 3, 4, 5 different functions. So let's keep cosine the same. And instead of tan, I'm going to put a bracket here, and I'm going to change it to sine squared over cos squared. This is cos squared over 1. Whenever you have some fraction times some fraction, I could cross cancel. These cancel completely. So I'm left with sine squared theta on the right-hand side. Anytime you do a couple of steps like that, it's good to pause and see what's going on the left side as well to make sure we're on the right track. We have sine squared on the right and 1 minus cos squared on the left. Anytime I see squares in my equation, especially when there's a 1 involved, I should try to think about my formula sheet. Right now, we're only dealing with the top left-hand side of our formula sheet, but you may notice that sine squared plus cos squared equals 1. Right now, we have sine squared theta in the question, and we have 1 minus cos squared theta in the question as well. Even though it's sine squared plus cos squared, we can manipulate this formula a little bit, and we could say that sine squared theta is equal to 1 minus cos squared theta. How did I get that? I took this term here, and I moved it to the right. So one of the things about this, or these 3 formulas I should say, is that we should be comfortable with moving any sort of piece of the formula around a little bit. So if I need tan squared to be negative, I can move tan squared over to the right, I can move secant squared over to the left, and then I get negative tan is equal to 1 minus secant. You can move any of these pieces around within their own formula. So it's formula 1, 2, and 3. Okay, so sine squared is equal to 1 minus cos squared. If that's the case, I can automatically change this to sine squared theta. And now I've proven that my left-hand side of the equation is equal to the right-hand side, and I have finished my identity. So this was on page 8, question B. The last one I'm going to do with you guys is on page 9. Question B as well. So this is secant over tan x plus cotan x equals sine x. I want to use the same concept that it's better to do everything in terms of sine and cosine, and then that way we only have two functions to look at. So on the left-hand side, I'm going to change everything right away in terms and change them into terms of sine and cosine. So secant is 1 over cos x. Quick note, if it's in terms of x, I got to keep it in terms of x, so you'll notice I didn't write theta in that case. Tan x is the same as sine x over cos x. And cotan x, although it is 1 over tan, in this unit it's better to think of cotan as cos over sine. So again, tan is sine over cos, so cotan is cos over sine. I'll leave the line down the middle for now because we know that sine x is the only thing on the right. I just don't have a ton of room in the booklet here to work with what we got. So let's just wait for a second here. So on top I have one fraction, but on the bottom I have two. It's a really good strategy when you have two fractions to combine them together. In order to combine them together, I'm going to find a lowest common denominator. And the easiest way to do that is to just basically multiply by whatever's missing in both denominators. So if one denominator is cosine and one denominator is sine, cosine is missing sine. And vice versa, sine is missing cosine. So on the left side here, I'm going to multiply by sine on the bottom, and I have to do the same to the top. And then on the right side, I'm missing cosine on the bottom, and I'm going to multiply by sine on the top. So you multiply by whatever's missing on the left and right. In question A, it's 1 minus sine and 1 plus sine. So I'm going to multiply this fraction by 1 plus sine and multiply this fraction by 1 minus sine. So if you're looking at the notes, that's why those get multiplied top and bottom by whatever's missing. Back to this one. Now the common denominator is the same for both. So on top, nothing changed. You still have 1 over cos, but on the bottom, the left fraction is sine cos, the right fraction is sine cos, and when you add or subtract fractions together, they go over their common denominator in the next step. The left numerator is sine squared x. The right numerator is, sorry, I wrote that wrong. Hopefully you guys caught that. Cos x there. So cos squared x. Should have been cos over cos. So hopefully you caught that before I did. So now we have one fraction over another fraction. It's always a good time to pause at this point now that we've done a couple of major steps. And you should evaluate what you have in the situation. So 1 over cosine really can't change too much. Sine squared x plus cos squared x over sine cos. You could look to cancel, but the problem is there's a plus sign in the middle, which means for the all or nothing rule, I cannot cancel anything in this question right now. What I do notice, though, is I see squareds for sine and cosine, and I also see a plus sign. Whenever I see squareds, I should think about my formula sheet. You'll notice that I did not start with the formula sheet, and that's because the original question did not have any squared values involved. Now that I've done some multiplying, I've got some squared values. Well, sine squared plus cos squared equals 1. So from our formula sheet, we'll keep the 1 over cos on top, but on the bottom, sine squared plus cos squared equals 1. And that is from the formula sheet. And that's all over sine cos. That is equal to 1 over cos times sine cos over 1. So I have, whoops, let's move that over a little bit. So I had a fraction over a fraction, so I flipped and multiplied, right? Dividing a fraction, I flipped and multiplied there. Coses cancel, 1s cancel. I'm left with sine which is equal to the right-hand side of the equation. Okay, so just to review, I put everything in terms of sine and cosine throughout. I had two fractions that I needed to combine to make one fraction, so I multiplied top and bottom by what was missing. I ended up with sine squared x plus cos squared x, which is directly from the formula sheet. You divided fractions, which means you flipped and multiplied, and you ended up with sine x, which is exactly what the right-hand side was equal to.